There is a question from redox reaction. On balancing the given redox reaction, they're asking us to find the coefficient which is A, B, and C. So here we are provided with some redox reaction. First, we have to balance that reaction and we have to find the values of A, B, and C, which is very easy. So we know the method to balance the redox reaction, right? So normally we'll be using half reaction method. So by using half reaction method, please balance the given equation and find the coefficients A, B, and C. So do you know how to balance redox reaction? Do you know how to balance this redox reaction? Okay. Marimuthu, do you know Kanna?
Oh, seven.
Malavika, Sachin. Okay, let us see how to balance this redox reaction. So balancing part is little different from the normal reaction. Okay, because in redox reaction, we'll be following some set of rules to balance the reaction. Okay. So here, first of all, the first step is you have to find which is getting oxidized and which is getting reduced. We have to write the oxidation reaction separately and we have to balance that. And we have to write the reduction reaction separately and we have to balance that. And finally, we have to add both oxidation and reduction reaction. Okay. So here, first let us understand which is getting oxidized and which is getting reduced. Here, this is Cr2O7 2 minus. Here the central atom is chromium. And first we have to find the oxidation state of chromium here. Could you please calculate the oxidation state of chromium in Cr2O7 2 minus? Cr2O7 2 minus. So we have to find the oxidation state of chromium. So we have two chromium here. Oxidation state of chromium to be calculated, which I'm going to take it as X, plus I have 7 oxygen and oxygen's oxidation state is minus 2, which is equal to total charge on the compound is minus 2. So what is the value of X? What is the value of X? What is the value of X? What happened, Kana? What is the value of X or what is the oxidation state of chromium? Yes, it is plus 6. Okay. So oxidation state of chromium is plus 6 in Cr2O7 2 minus. And in product side, the oxidation state of chromium is 3 plus. So basically, chromium is getting reduced. Okay. And basically here, it was sulfite, which is SO3 2 minus. And this is getting converted into SO4 2 minus. Here, the oxygen was added. So this is the oxidation reaction. So I'm going to write the reduction reaction and oxidation reaction separately and I'm going to balance both the reactions. So the reduction reaction is Cr2O7 2 minus, which is getting reduced to chromium 3 plus. Please, you just forget about all those coefficients. Now we're going to balance this reaction, okay? And we'll end up with the coefficient of all those species now. So whenever you're balancing the redox reaction or oxidation reaction separately, please follow these steps. Okay. Here, first you have to balance the main atom, which is considered to be the main atom except oxygen and hydrogen. Rest of the atoms are considered to be the main one. Here, except oxygen, we have chromium. Left side, we have 2 chromium atoms and right side, we have only 1 chromium atom. So we have to balance chromium. So how many chromium I should add on the right side? 2 chromiums. So the main atom is balanced. Now we have to balance the oxygen. Left side I have 7 oxygen and right side I have no oxygen. So right side I have to add 7 oxygen. So you to add oxygen, you have to add oxygen through water molecule. So in one water molecule, we have 1 oxygen. So I have to add 7 water molecule to add 7 oxygens, right? That's it. So main atom is balanced. Now oxygen is also balanced. Now the problem is with hydrogen. Left side I have no hydrogen, but right side now we added water molecule, right? So there we have hydrogen atoms. How many hydrogen atoms are there in? How many hydrogen atoms are there in the right side? We have totally 14 hydrogens, right? Because we have 7 water molecule and each water molecule got 2 hydrogen atoms. So totally we have 14 hydrogens in the product side. So in reactant side also I have to add 14 hydrogens. So here hydrogen has to add through H plus ions. So totally I have to add 14 H plus ions in the reactant side. So main atom is balanced, oxygen is balanced. Now hydrogen is also balanced. Now we have to balance the charge. Okay. So left side, how many charges I have? Here in Cr2O72 minus, I have 2 negative charge, and here in one H plus ion, I have 1 positive charge. But here I have 14 H plus ions. So how many positive charges I have? 14 positive charges. So totally in reactants, I have 12 positive charges. Right here, this is 2 minus, and here this is 14 plus. So totally in reactant side, I have 12 positive charges, and in right side or in product side I have 6 positive charges, right? Because in one chromium ion I have 3 positive charge, so I have two chromium ion in the product side, so totally I have 6 positive charges. So here charges are not equal, and we have to balance the charge using electron. So electrons are negatively charged, so we have to add electrons to the side where positive charges are more. So to balance the charge, left side I have 12 positive charges, and I have to make that 12 positive charges to 6 positive charges to balance it to the right side, right? So how many electrons I have to add to left side to make it as 6 plus? Totally I have 12 positive charges. How many electrons I have to add to the reactant side to make it as 6 plus? How many electrons kana? 6 electrons, that's it. So I've balanced the main atom, I've balanced hydrogen, oxygen, and now the charges also. Now this reduction reaction is balanced. And similarly, we have to balance the oxidation reaction also. So what is the oxidation reaction? Here SO3 2 minus is getting oxidized to SO4 2 minus. Now here the main atom is sulfur. Sulfur is already balanced. Now we have to balance the oxygen atom. Left side I have 3 oxygen atoms, and right side I have 4 oxygen atoms. So one oxygen atom is extra in the product side. So I have to add one more oxygen to the reactant side, and I have to add oxygen through water molecule. So I have to add one water molecule to add one oxygen. So now I have added extra 2 hydrogens to the left side. So I have to add 2 more hydrogens to the right side also. So hydrogens are added through H plus ions. So two times of H plus ion at the right side. So I have balanced the main atom, I have balanced oxygen, and now hydrogen is also balanced. Finally, we have to balance the charge. Left side we have totally we have 2 negative charge, and right side we have 2 negative charges and 2 positive charges. So basically we have 0 charge at the product side. So how many electrons we need to add to the right to get 2 negative charges? How many electrons has to be added in the product side to make it as 2 negative?
4, ma'am.
Right side we have 0 charge, and we have to make it as 2 minus. So how many electrons we have to add? Left side we have 2 negative charges, and we have to make the right side also right side charges also has to match with the reactant side. So we have to add 2 electrons, right? So to the product side I'm going to add 2 electron. That's it. So oxidation reaction also balanced. So we have to add these 2 reactions. Before adding the oxidation and reduction reaction, we have to make sure that both the reaction have equal number of electrons. But here First reaction got 6 electrons and second reaction got only 2 electrons. So to make them equal, I'm going to multiply the second equation by 3. Okay. So if we multiply it with 3, then what we'll get? 3 times of SO3 2 minus plus 3 times of H2O gives 3 times of SO4 2 minus plus 6 times of H plus 6 times of electron. Now this equation and this equation got equal number of electrons. So I'm going to add both the equations. Now I'm going to add equation 1 and equation 2. Okay. So while we are adding the equations, we have to cancel the common terms which are present at the opposite side. So here I have 6 electron, here I have 6 electron cancelled out. Okay, so what are all the remaining species which is at the reactant side? Cr2O7, 2 minus. Here I have 14H plus, right? And reactant side I have 3 times of SO3, 2 minus, and I have 3 times of H2O. And in product side, I have 3 times of SO4, 2 minus, 6 times of H plus 2 times of Cr, that is chromium 3 plus, and 7 times of H2O. Still we have few common terms, right? Here we have 3H2O and here we have 7H2O. So please bring this 3H2O to the right. Okay. So what will happen? What will happen, Kana? And also we have 6 H plus ions. So please make them equal or please simplify those H plus ions. So what will happen? So please bring the 6 times of H plus to the left. So already I have 14 times of H plus at the reactant side. So 14 minus 6 is 8, right? So what will be the final expression? Cr2O7, 2 minus plus how many times of H plus? 8 times of H plus and 3 times of SO3 2 minus, which gives how many moles of SO4 2 minus? It is just 3 moles, right? So 3 moles of SO4 2 minus. Here now we don't have H plus ion at the product side and 2 times of chromium 3 plus and how many water molecule? 4 times, right? That's it. I mean, how many water molecule? Already we have 7H2O. Right side I have 3H2O. So I'm bringing the 3 times of H2O to the right side. So 7 minus 3, which is 4. So this is the balanced equation of the given redox reaction. Okay. So we have to find the value of X. I mean, A, B, and C. A is the coefficient of chromium, which is 1. So option A and C were ruled out. And coefficient B is the coefficient of SO3 2 minus. So here it is 3. So what must be the answer then? C is the coefficient of H plus ion. So 1, 3, 8. So this is the coefficient of chromium. 3 is the coefficient of SO3 2 minus and H is the coefficient of H plus ion. So obviously the answer is option 2. That's it. Okay. Do you have any doubt? Shall we move on to next question? Okay. See, this is very easy. They're asking us to match two lists. So here we have few oxyacids of sulfur and in second list they have given the number of few chemical bonds. So we have to match that. For that, basically, we need to know the structure of all those oxyacids. So, of course, you know the structure of sulfuric acid. Of course, you know the structure of sulfurous acid also, but you have to know the structure of peroxide disulfuric acid and pyrosulfuric acid. So this is from P block element. Could you please guess the answer? If you couldn't, you just let me know. We'll try together. Now, what is the structure of sulfuric acid? Or what is the formula of sulfuric acid?
H2.
H2SO4. So here the central atom is sulfur and the structure of sulfuric acid is S double bond O, OH and OH. Right. So we have to match the structure of sulfuric acid with the number of chemical bonds given in the list 2. So can you please match the structure of sulfuric acid with the number of chemical bonds given in the second column? So here, how many sulfur oxygen double bonds are there? Two sulfur oxygen double bonds, right? So in first option, they've given us four sulfur oxygen double bond. So this will not be the answer. And here they got only one sulfur oxygen double bond. So this will not be the match. So of course this one, fourth one, right? So in fourth match they've given us two sulfur oxygen single bond and two sulfur oxygen double bond. So in sulfuric acid we have sulfur oxygen double bond two numbers and sulfur OH bond two numbers. So the structure of sulfuric acid is matching with this match. So B has to be matched with fourth one. So of course, second and fourth option were ruled out. Okay, among first and third option, we have to find the right one. Is there any other possible structures you can draw, Kana? What is this pyrosulfuric acid? Any idea? What is pyrosulfuric acid? Actually, pyro means dye. Yes, Kana? Yes, Antana Maharaj?
Ma'am, SOS, it has one SOS, ma'am.
Okay, so C has to match with the first one. Okay, we'll see. Actually, pyro means dye. So we have to take two sulfuric acid molecule and we have to remove one water molecule between them. So we know the sulfuric acid structure as S double bond O, OH and OH. And here I'm going to write another sulfuric acid molecule. So between these two sulfuric acid molecule, we have to remove one water molecule. So H2O. So after removing the water molecule, we can write the final structure as S double bond O, OH, single bond oxygen, sulfur, double bond O, OH. So in pyrosulfuric acid, we have sulfur oxygen sulfur bond as in the first match. So C has to connect it with first one. So obviously the answer is third option. Okay. What is this peroxo? Which means the
Yes,
name itself. Yes, Kanna, yes.
yes, double OS, ma'am.
That's it. So actually, that acid structure should have peroxide bond. So what is peroxide bond? Oxygen, single bond oxygen. That's it. So in the given match, only this got sulfur, oxygen, sulfur. So this got peroxide bond. So definitely A has to match with third one. Okay, fine. So shall we move on to next question?
Yes, ma'am.
Okay. So here Basically, this question is from mole concept, which is very easy. What mass of 95% pure calcium carbonate will be required to neutralize 50 ml of zero point 0.5 molar HCl solution according to the following reaction? So the given reaction is calcium carbonate is reacting with 2 moles of HCl to give calcium chloride, carbon dioxide and 2 moles of H2O. Whenever the reaction is given, we have to make sure whether that is balanced one. Okay, whether this is balanced one or not,
Balanced, ma'am.
balanced, so we have no problem. And the basic inference from this balanced equation is, so calcium carbonate is reacting with HCl. So hydrochloric acid is an acid. Calcium carbonate is a base. So basically this is a neutralization reaction. So we'll end up with a salt. Okay. Here, 1 mole of calcium carbonate is reacting with 2 moles of HCl to give 1 mole of calcium chloride, 1 mole of carbon dioxide, and 2 moles of H2O. So here, the ratio between calcium carbonate and HCl is 1:2. So this is our inference. Okay, here in given data, the HCl they've taken is 50 ml of zero point 0.5 molar concentration, right? So from the concentration and volume, please find the number of moles of HCl they have taken. Number of moles of HCl they have taken. So what is the relationship between concentration, volume and number of moles? Concentration is equal to number of moles by volume. Now we have to calculate the number of moles of HCl. So we have the concentration as 0.5 mole per liter and volume as 50 milliliter. So what is the number of moles, Kanna? Liter and per liter will get cancelled out. So we'll get number of moles in millimole. So how many millimoles of HCl they have taken?
The given equation is imbalanced statements, no, ma'am. If hydrogen is not balanced.
Okay. So how about oxygen? Is it balanced? Here we have 3 oxygen atoms. Here we
Yes.
have 2 oxygen. So without having the 2 H2O, it is already balanced, right? So is it balanced now, Santana Maharaj?
Yes, ma'am. Now it's balanced.
Okay, right. Thank you. Thank you, Kanu. Fine. So how many number of moles of HCl they have taken? 25 millimole, right? So according to the given data, HCl taken is 25 millimole. So what quantity of calcium carbonate we required for complete neutralization?
12.5 millimole, ma'am.
Very good, 12.5 millimole, because the inference is quantity of calcium carbonate has to be half the quantity of HCl. So here the quantity of HCl is 25 millimole. So the quantity of calcium carbonate required for complete neutralization is 12.5 millimole. Okay. Here the calcium carbonate was not 100% pure, that is just 95% pure. So it is not 100%, it is just 95%. So we have to calculate what quantity of calcium carbonate required for complete neutralization. And here the quantity was given in grams and not in number of moles. So here we have to convert this number of moles of calcium carbonate to weight or in terms of gram. After which we have to calculate how much gram of 95% calcium carbonate required for complete neutralization. So first find the gram of calcium carbonate from this 12.5 millimole. So what is the relationship? Number of mole is equal to given mass divided by molar mass. Number of mole is 12.5 millimole. And what is the molar mass of calcium carbonate? What
100
is
gram.
very good? 100 gram per mole. So what is the quantity, Kana? How much milligram there? How much milligram?
1250 milli.
Okay, 1250 milligram or 1.25 gram, right? So if my calcium carbonate was 100% pure, then I need 1.25 gram of calcium carbonate. But unfortunately, the calcium carbonate was just 95% pure. So which means if I take 100 gram of calcium carbonate, in which I'll be having only 95 gram of calcium carbonate, right? Now, how much gram of calcium carbonate I need? According to this calculation, we need 1.25 gram. So, which means how much gram of 95% pure calcium carbonate I have to take? Just cross multiply it and let me know the value of X.
1.32 gram, ma'am.
That's it. So, answer is 1.32 gram. Okay. Now, we move on to next question. Ah, this is very easy. The question is from atomic structure. Very easy. We are provided with four statements and we have to find the wrong statement. Right, Marimutu. Answer is 1.314. So among the given statements, which is the incorrect one?
Option 2, ma'am.
Option?
Option 3, ma'am. 3 is incorrect.
Okay. Can you please justify your statement?
4D orbitals have different shape from 3D orbitals.
Really? See, generally, we have five d orbitals, right? Whether
Same
it
shape.
is present in. Sorry, Santramaraj?
I think its size increases.
Size increases, but not the shape.
But not shape.
So let
So
me write these structures. Yes, yes, Kana.
option D.
Option? You're telling me option D, right?
No, 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 no. I confused me. I'm sorry.
Okay, okay, okay. I've seen the answer of Takritika. It is option A, it seems. Okay. Her
Ma'am,
option. Yes, Kana, yes.
dxy, dyz, and dzx, and dx square minus y square having similar energy, ma'am. And dz square differs in it, I think, ma'am.
Okay. We'll see Tatratika. Okay. Padma Selva. And his answer was fourth option. Okay, we'll check. Okay. So before that, we have to know the shape of all the five d orbitals. So d in d subshell, we have five d orbitals, right? And all the d orbitals have same energy. So all these five d orbitals are called degenerate orbitals. Okay. So in d subshell, we have five orbitals and all the five d orbitals will have same energy. So they are called degenerate orbitals. So according to fourth statement, in an atom, all the 3d orbitals are equal in energy in free state. This is right. Here the statement is true. Okay. Why they have mentioned about free state? Because whenever this D block element is combining with any ligand to form a complex, there will be a splitting of orbitals, right? So after splitting, they don't have equal energy, but in free state all the d orbitals will have equal energy. So fourth statement is right. Okay, now let me write the structure of all the 5d orbitals. So what are all the d orbitals we have? Dxy, yz, zx, dx square minus y square, and dz square. Okay, so this is x-axis, this is y-axis, and I'm going to write the structure of dxy. Here, the structure is clover leaf shape. So I'm going to have two dumbbell shapes between x and y-axis. So this is the structure of dxy. And now I'm going to write the structure of dyz. This is y-axis and this is z-axis. Now the electron density or the lobe is present between the axis. And this is the structure of dzx. So this is z-axis and this is x-axis. Now the lobes are between z-axis and x-axis. Now I'm going to draw the structure of d x square minus y square. This is x-axis and this is y-axis, and the electron density is on x-axis and y-axis, right? And finally, this is the structure of d z square. Let us take this as z-axis. Now I have one dumbbell shape and I have one donut shape, right? So this is the structure of dz square. See, now the shape of dxy, yz, zx and dx square minus y square are similar, but the shape of dz square is completely different, right? So, what is the first statement? The shapes of dxy, yz, zx orbitals are similar to each other, and dx square minus y square and dz square are similar to each other, which is wrong. Shape of dx square minus y square and z square is completely different. So, first statement is false. Okay, so according to this question, this is the right answer. Now, let us see the second statement. All the 5d orbitals are different in size when compared to the respective 4d orbitals. Of course, see here this is fourth shell, this is fifth shell. So as n value increases, size of the orbital increases and not the shape, right? So the statement is true. And third statement, all the 5d orbitals have shapes similar to the respective 3d orbitals. See the shape of 3 dxy and 4 dxy are same, right? The shape of 3 dx square minus y square and 4 dx square minus y square are same, right? Here the n value is getting increased and shapes are same for dx square minus y square and I mean for both the orbitals, right? So the statement is also true. So the false statement is first one, because four d orbitals will have similar shape and dx square minus y square will have different shape. Okay, that's it. So next question. So the right answer is first option. Okay, here they've given some atomic number and they're asking us to write the IUPAC name for that element. Very easy.
Option B, ma'am.
Option D, right. Option B, right. So if it is 0, what is the term, Kana?
Nil, ma'am. Nil.
Nil, nil. If it is 1, then and
June, ma'am.
if it is 2,
By.
by. If it is 3, Tri. If it is 4, quad. If it is 5, pent. 6 is hex. 7, sept. Sept. 8 is oct. 9 is een. Okay. And what is the symbol of this element? See, 1 means it is un. So the first letter is U. U, U,
UUE.
E. That's it. Next question. Among the following, which one will have maximum lone pair repulsion? Okay. So first we have to find the hybridization of central atom and the structure, and we have to find which structure got more lone pair repulsion. So first find the hybridization. First we'll start with the XCF2. Could you please tell me the hybridization of xenon? Siddhamachan wrote all those names. Good Siddhamachan.
SP3D.
SP3D, right. So xenon can form 5 chemical bonds, 1, 2, 3, 4 and 5. But in this molecule, xenon got only 2 fluorine as terminal atoms. So I'm going to have 2 fluorine atoms, one at the top, another at the bottom. So I have 3 empty bonds. I'm going to fill it with lone pair of electron. So what is the shape of this molecule? Originally it was trigonal bipyramidal, but now it is, yes, Tatvatika.
Linear.
Very good, it is linear. Okay, second one, ClF3, hybridization of chlorine.
SP3, ma'am.
Can you please check
SP3D.
it again?
Same hybridization SP3D.
SP3D. Maributhu, it is SP3D. Okay. So again, chlorine can form 5 chemical bonds, but chlorine got only 3 terminal atoms. So 1, 2, 3, and empty bonds are filled with lone pair of electrons. So the shape is T shape. Okay. Okay. Next, IF5. Hybridization of IF5.
SP3D2.
Okay, SP3D2. What could be the shape, Kana? Iron can form. Iron can form 6 chemical bonds. 1, 2, 3, 4, 5 and 6. But iron got only 5 fluorine atoms. 1, 2, 3, 4, 5. Now I have one lone pair of electron here. The original shape was octahedral, but in octahedral we got one lone pair of electron. Now the shape is square pyramidal.
Pyramidal.
Okay. SF. SF. Hybridization of sulfur.
SP3D, ma'am.
SP3D. So sulfur can form 5 chemical bonds, 1, 2, 3, 4 and 5. So sulfur got 4 fluorine atoms, 1, 2, 3 and 4. So what is the shape of this compound?
Bend D shape.
Mhm. Seesaw, or it is also called as distorted tetrahedral. Okay. Now tell me which molecule got more lone pair repulsion.
Students, whatever information உங்களுக்கு இப்போ we are having one class per week. That will be very good.
Which got more number of lone pair of electron?
So we are going to
A,
have
ma'am.
second class per
A.
two class per week.
Okay. So answer is option A.
First mail.
Kaviraj is asking me how to find hybridization of the molecule. Okay, we'll do it for one molecule, Kaviraj.
வேற என்ன தேவையோ அதெல்லாம் பண்ணுவோம். அதுக்கு
Which molecule you want me to calculate?
டைம் 7 மணியே வச்சுக்கலாம். இன்னும் one more day we will keep it. சரிங்களா? எத்தனை
Calcium.
அப்படிங்கிறது நம்ம குரூப்ல நம்ம டிஸ்கஸ் பண்ணுவோம்.
Kana, for actually hybridization is meant for the molecule. Okay, calcium is an atom. Okay, wait. Let me take one random molecule and we'll do hybridization.
சயின்ஸ்னா உங்களுக்கு ஃபிசிக்ஸ் கெமிஸ்ட்ரி மேத்தமெட்டிக்ஸ் இந்த மாதிரி ஏதோ ஒன்றுங்க இல்லை ஓகே தேங்க்யூ.
Okay, so let us take a PCl5. Okay, now hybridization is used to find the shape of the molecules. Okay, each molecule will have a different shape. It is not like our atom. Generally atoms are spherical in shape, but molecules are different from each other. Okay, so to find the structure of molecule we are going for hybridization. So whenever a molecule is given, we have to find the hybridization of the central atom. Here in PCl5, the central atom is phosphorus. So now we're going to find the hybridization of phosphorus. So the first step is we have to write the number of atoms which are present in this molecule. So we have phosphorus and we have chlorine. How many phosphorus atoms is there in PCl5? Only one. So 1 into, we have to multiply this number of phosphorus atom with valency electron of phosphorus. So what is the valency electron of phosphorus? It is in 15th group. So what is the valency electron of phosphorus?
4.
Uh-huh. See, if the group number is 15, then the valence electron is 5. Okay, so in 15th group we have nitrogen, phosphorus, arsenic, antimony, bismuth. Okay, so since phosphorus is in 15th group, valence electron is 5. So 1 into 5 is 5. And in PCl5, number of chlorine atom is 5 and the number of valence electron of chlorine is in 17th group. So what is the valence electron of chlorine?
7.
7. So 5 into 7 is 35. So 35 plus 5 is 40. Okay, so this is the total valence electron. After finding the total valence electron, compare this total valence electron with the number 9. If the total valence electron is less than 9, then divide this total valence electron by 2. If total valence electron is greater than 9, then divide total valence electron by 8. Total valence electron will never be equal to 9. Okay, so here this is greater than 9, so we have to divide this total valence electron by 8. So how many times? 5 times, right? So remainder is 0. That's it. So from this quotient we can find the hybridization. If the quotient is 2, then the hybridization is Sp. Power of S is 1, power of P is 1, 1 plus 1, 2. If quotient is 3, then the hybridization is Sp2. Power of S is 1, power of P is 2, 1 plus 2 is 3. If quotient is 4, then the hybridization is Sp3. If the quotient is 5, then the hybridization is Sp3d. If quotient is 6, then the hybridization is Sp3d2. If quotient is 7, then the hybridization is Sp3d3. Okay, so here the quotient is 5, So the hybridization is sp3d. Okay, for each hybridization there is a shape. Okay, so here this is sp3d, so which means the central atom can form 5 chemical bonds, because the power of s is 1, power of p is 3, power of d is 1, so 1 plus 3 plus 1 is 5. So phosphorus can form 5 chemical bonds, and the shape was 1, 2, 3. 3 bonds were in plane and 2 bonds were out of plane. Here I have 5 chlorine atoms attached. That's it. So the shape of this molecule is trigonal bipyramidal. On top of the plane we'll be having one pyramid, and bottom of the plane we'll be having another pyramid. So we have two pyramids. So it is called as trigonal bipyramidal. That's it. So accordingly, see here in CLF3, or first we'll see for SF4. Okay, in SF4 the hybridization was found to be sp3d. Okay, by using the same rules we can find the hybridization of sulfur, which is sp3d. So sulfur can form 5 chemical bonds, right? So I have 5 chemical bonds around sulfur, but in this molecule I have only 4 fluorine atom, but in this previous case there were 5 chlorine atoms, so all the bonds were connected with atoms. But here we have only 4 fluorine atoms, so one bond was empty, right? So in empty bond we have to fill it with lone pair of electron. Originally the shape was trigonal bipyramidal, but in trigonal bipyramidal we got one lone pair of electron, right? So if we got one lone pair of electron, because of the repulsion between lone pair of electron and the bond pair of electron, the original shape was distorted. So the shape will not be trigonal bipyramidal. Instead, it is getting converted into seesaw, or the structure is also called as distorted tetrahedron. Okay. Similarly, in CLF3, the hybridization was found to be sp3d, and chlorine can form 5 chemical bonds, but unfortunately we have only 3 fluorine atoms. So only 3 bonds were connected with atoms, and I have 2 empty bonds, and both the empty bonds were filled with lone pair of electron. Now this structure got 2 lone pair of electron. In trigonal bipyramidal, if we got one lone pair of electron, the structure was seesaw. If we got 2 lone pair of electron, the shape was T shape. Okay. In XCF2, the hybridization is sp3d again, and xenon can form 5 chemical bonds, but here xenon got only 2 fluorine atoms, and both the fluorine atoms were here, and all the 3 chemical bonds were filled with lone pair of electron. Now the trigonal bipyramidal structure got 3 lone pair of electron. Now the shape is linear. Okay, and actually we have a complete tabular column for this structures, Kana. While I'm giving you the notes, I'll attach that also. Please revise that, Kaviraj. Okay.
Okay, ma'am. Thank you, ma'am.
So now we'll move on to next question. Which among the following is incorrect statement, which is very easy. So we have to find whether this O2 plus is a diamagnetic species, and we have to find the bond orders. And the third statement is C2 molecule has 4 electron in its 2 degenerate pi molecular orbitals, and fourth statement is H2 plus ion has 1 electron. Find which one is incorrect. See, for bond order calculation and all, you need not draw this MOT diagram. You can use the shortcut to find the bond order. For finding the magnetic behavior, you have to write. You have to draw the structure. But if you're thorough with the oxygen, nitrogen, MOT diagram, then again you need not draw the structure. You can definitely guess the answer.
I think option A is incorrect, ma'am.
Okay, why?
It has odd number of electron, ma'am.
Odd electron in the sense?
O2 plus has 6 plus 5, 11 electrons, ma'am.
Okay.
So a single orbit is not full, ma'am. So I think
Okay,
it's there,
fine.
not a
Fine.
diamond.
Okay. So according to MOT diagram, we know that oxygen molecule got two unpaired electrons in the antibonding molecular orbital, right? So that is why O2 molecule is paramagnetic. Do you remember the MOT diagram? So we'll be having two unpaired electrons. So that is why oxygen molecule is paramagnetic. But in O2 2 plus, we removed one electron. So still we have one unpaired electron left. So it is again paramagnetic and it is not diamagnetic. Okay. So if anyone want me to draw the structure of MOT of oxygen, do you remember the structure? Okay,
நம்ம
fine.
வந்து ஆட் நம்பர் ஆஃப் எலக்ட்ரான் இருந்தாலே பாராமேக்னெட்டிக் போடலாமா மேம்?
நோ கண்ணா. ஆக்சுவலி அது வந்து ஒரு எல்லா
அது
மாலிகுலுக்கும் அது
full
ஒர்க்
ஆகாது
ஆகுமான்னு
மேம்.
தெரியாது.
ஒரு ஆர்பிட்டல்ல பேரானாலும் ஃபுல் ஆகாதுல மேம். ஒரு இது வந்து எக்ஸ்ட்ரா தானே மேம் இருக்கும்.
அது எல்லா ஸ்பீஷிஸ்க்கும் அப்ளை பண்ணி நம்ம பார்க்கல இல்லைங்களா? அதனால அப்படி போட முடியாது சந்திரமாயிராஜ். அதுக்கு சேஃப் வந்து டயக்ராம போட்டு போட்டிருக்கோம். இல்லைன்னா நம்ம ஞாபகம் வச்சிருந்தோம்னா பிரச்சனை இல்லை. எப்படி இருந்தாலும் they gonna ask it from oxygen or nitrogen, that's it.
ஓகே.
So second option is they're talking about bond orders of O2 plus, O2, O2 minus, and O2 2 minus, and we have to find whether these bond orders are right. But here this is only one answer right, so first option will be the answer. Okay. If you want me to draw the diagram, you just let me know. We'll draw, or we'll move on to next question. Shall we move on to next question?
எஸ் மேம்.
Okay. Which of the following pressure volume curve represents the maximum work done? Basically, area under the curve represents work. So if the area is more, maximum work. So
ஆப்ஷன்
which
சி
is the
மேம்.
answer? Obviously, option C. That's it. Next question. Okay. The pH of the solution containing 50 ml of each of 0.1 molar sodium acetate and 0.01 molar acetic acid is. pKa of acetic acid is given as 4.57. So obviously the question is from ionic equilibrium. We have to find from which concept this question is asked.
காமன் அயன் எஃபெக்ட் மேம்.
Yeah, kind of. But is there any pH related concept we have studied in common ion effect? I want you to tell the specific subtopic. Very good, buffer solution, because here the combo is weak acid and its conjugate base. So they are talking about acidic buffer. So we know the formula to calculate the pH of acidic buffer, right?
Yes ma'am.
So what is the formula?
pH is equal to pKa plus log base 10 conjugate base by weak acid ma'am.
Okay.
Concentration of conjugate base by the concentration
Right.
of.
So to find the pH of acidic buffer, the formula is pH is equal to pKa plus log concentration of salt by concentration of acid. That's it. So they're asking us to find the pH. So pH is equal to pKa is given as 4.57 plus log concentration of Salt is sodium acetate and its concentration is 0.1 molarity, which is 10 power minus 1. And the concentration of acid is 10 power minus 2. Please simplify this and tell me the value of pH.
5.57, ma'am.
5.57, yes. Right, Marimuthu, answer the second option. 5.57. That's it. Now this question. Identify the incorrect statement from the following.
Yes, block is deleted, ma'am.
Yes, Kana, it is deleted. But if you want to try, you can try, or we'll move on to next question. But this is very easy one. By just seeing the statement itself, you can find which one is wrong.
Option D, ma'am. No, ma'am. Sorry, ma'am. Option D is correct.
It is right.
Yes, ma'am. Sorry.
No, Kana, no, Marimuthu. The second option is also right. Usually, metal hydroxide, whenever alkaline metal or alkaline earth metal, whenever it is reacting with water, it will get converted to hydroxide. See, calcium can form hydroxide, right? Calcium hydroxide. Yes, Antana Maharaj?
Option C.
Option C, obviously. Because, see,
Plus
in
oxidation.
whenever the potassium is getting converted into a compound, potassium's oxidation state will be definitely +1 and not +4, right? So obviously the answer is option C. S block is deleted, but I thought this is quite interesting because without even getting into deeper, by just seeing the statement, we can find the answer, right? So that is why I've taken this question. Okay, so this is from electrochemistry or redox reaction. We are provided with some electrode potential. Please make sure whether the potential is reduction potential. After which we are provided with some equations and we have to find which cannot occur. Tatvatika, this question is also from physical significance of electrode potential.
Okay, ma'am.
Please make sure whether the potential is reduction potential or not. If it is oxidation potential, please convert that into reduction potential and apply it.
Everything is reduction potential, ma'am. Option
Okay.
A, ma'am.
Okay, fine. Could you please justify your answer?
And AG has a higher reduction potential, ma'am.
Okay.
So compared to Cu, ma'am.
Hmm.
So it will not oxidize when we put CuSO4, ma'am. It
Yes.
will, ma'am.
Yes, that's it. See, in first reaction, they are connecting copper and silver, right? So what is the electrode potential or reduction potential of copper? Which is 0.34, right? And silver is 0.80. This is copper and this is silver, and we know the shortcut as electron will be moving from negative terminal to positive terminal or smaller value to larger value. Here electron will be flowing from copper to silver. So silver will gain electron, so it will get reduced, and copper will lose its electron, so it will get oxidized. So whenever copper and silver are connected together, silver will get reduced and copper will get oxidized. So in first equation, here copper was reduced and silver was oxidized, which is wrong. So answer is first option. Okay. You just check it for the rest of the options. All the reaction will occur. Okay. Fine. Shall we move on to next question?
Yes, ma'am.
This one. 1 molar solution that contains 0.5 mole of a solute, there is dash quantity of solvent. They have given the molality, they have given the number of moles of solute, and they are asking us to find the quantity of the solvent.
500 gram of solvent, ma'am.
500 gram of solvent. So what is the formula? Molality is equal to number of moles of solute divided by weight of the solvent. Right?
Kilogram.
So here, yes, definitely in kilogram. Here, molality is 1 and number of mole is 0.5. So W1 to be calculated. So W1 is equal to 0.5 kilogram, which is 500 gram. So answer is option C. In 19th question, which one is not correct mathematical equation for Dalton's law of partial pressure? Here, small p is the total pressure of gaseous mixture. We have to find the wrong mathematical equation which is not related to, or the mathematical equation which is not related to Dalton's law of partial pressure. See, all the 4 equations might be right, but we have to find which is not related to Dalton's law of partial pressure.
Actually, it's deleted one, ma'am.
No, it is not deleted.
Gas is cheap, ma'am.
No. See, that point. See, Dalton gaseous state is deleted, but we have studied this Dalton's law of partial pressure concept in other chapters.
Yes, solution like.
Yeah, in solution also. In solution and in equilibrium, we have studied all those concepts.
Yes, ma'am. Option B correct, ma'am. Option C correct.
Okay. Marimuthu's answer is option A. Interesting. Yes, Marimuthu, could you please justify your answer, Kanna? Senthamil Chelvan's answer is option D. Okay.
Ma'am, partial pressure is equal to mole fraction time. Vapor pressure is in pore state, ma'am.
Vapor pressure is in
Pure state, ma'am.
pure state. Okay. Okay, Kanna. Senthamil Chelvan,
Yeah.
could you please justify your answer, Kanna? Why it is option D?
And I thought the pressure should be for the pure state, ma'am.
Okay, right. Yes, Santana Maharaj, you're about to tell me something.
I think option D.
Okay. We'll see. Any other answer?
Oh, what's the full form of P, ma'am? In D.
This is total pressure.
Okay.
Okay. Let's see. Let us discuss this question. In chemistry, we have studied 2 types of partial pressures, or we studied partial pressures in 2 different scenarios. In one scenario, see, I have a container full of gas, which means I have 3 types of gas. For example, A2, B2, and C2. Okay. Here, the pressure of A2 inside this cylinder is considered to be 3 atmosphere, and this is 4 atmosphere, and this is 2 atmosphere, and all the 3 gases are non-reacting gases. So what will be the total pressure inside this container? What will be the total pressure inside this container?
9, ma'am.
9 atmosphere. Okay, so this is Dalton's law of partial pressure. So total pressure inside the container is equal to the partial pressure of the gases which is present inside the cylinder, and all those gases are non-reacting gases. Okay, so here total pressure is equal to the sum of partial pressure. Here partial pressure is the pressure contributed by individual gases to the total pressure. Okay, so here they are talking about gaseous mixture. Okay, and in gaseous mixture, if we want to find the partial pressure of any gas, then we can use this formula. Partial pressure of any gas, which is equal to mole fraction of the gas into total pressure. So if we have any gaseous mixture and we have to find the partial pressure of any specific gas, then we can use this relationship. So this is also meant for gaseous mixture and this is also meant for gaseous mixture. Okay, and this can also be written as, see, we know PV is equal to nRT, right? So pressure can be written as nRT divided by V. So that is why instead of P1 they have written as N1 RT by V, N2 RT by V. So this is similar to this one. So we know second option is related to gaseous mixture, and obviously second and third options are similar, so both were related to gaseous mixture, of course. And as I've told you, partial pressure is equal to mole fraction into total pressure is also for the gaseous mixture. This is also right. So this is the scenario number 1. But second scenario where we discussed partial pressure is in solution, where I'll be having a solvent into which I've dissolved a quantity of gas, right? Initially, I had pure solvent. On the surface of the solvent, I had the vapors of the solvent, right? Let us say this is A liquid, and definitely I'll be having the vapors of A on the surface, into which I'm dissolving the gas B. So definitely I'll be having the I'll be having the gases of B on the surface. So here I have two vapors. One is due to A and another is due to B, right? So in this equation, what they are talking is, this is Pi, which is the partial pressure of gas, which is on the surface of the solution, right? And here this is the mole fraction of the gas which is present inside the solution, and this is the vapor pressure of the pure solvent. Here the vapor pressure we are talking about is in the solution, right? So here we have dissolved a particular quantity of gas inside the solvent, so due to which there is a pressure exerted on the surface of the solution. So here the pressure exerted on the surface is due to the gas which is dissolved inside the solution. So here we are not talking about the gaseous mixture. Here the concept is about solution, and rest of the equation we are talking about the partial pressure which is in the gaseous mixture. So though both the terms are similar, the actual meaning is different now. So first one is the odd one out. So that is not the equation which is related to Dalton's law of partial pressure. Okay. So here, this is the partial pressure of the gas on the surface of the solution. And here, this is the vapor pressure of the solvent, right? So this is different from the Dalton's law. Okay. You're getting my point?
Yes, ma'am.
Fine. Next question. Here we are provided with two equations and respective electrode potentials, and we have to find whether this permanganate ion will liberate oxygen from water in presence of an acid. They are talking about some process where MnO4 minus is reacting with water molecule, to give oxygen gas, and they're asking about the spontaneity or feasibility of the reaction. So again, it is from electrochemistry, but without getting, I mean, before getting into the equation, please check whether the given potentials are electrode potential, I mean, reduction potentials. We want to be very careful. See, here the equation is reduction reaction, no doubt about it. And here they've given some representation. And could you please check according to this representation whether the potential is oxidation or reduction potential?
Oxidation.
Reduction, ma'am.
Okay. So here manganese is in +2 oxidation state. Here manganese is in +7 oxidation state. So the representation is oxidation reaction. Okay, so the given potential is oxidation potential and not reduction potential. So from this equation, you should not consider whether, consider this as the reduction potential. You have to check for the representation also. If there is no representation, along with this equation, if they've given the value, then you can take it as reduction potential. But here instead, they have given the representation. So you have to give importance to the representation and not to the equation. Okay. So here the process is oxidation potential, oxidation representation. So here the value is oxidation potential. So what is the reduction potential then?
1.510, ma'am.
That's it.
Ma'am, I think no, because
Okay, this is reduction potential. Fine, we
no, because
converted.
minus 0.287 volt, ma'am.
We'll check, Satyaramay Raj. And could you please tell me whether this is oxidation or reduction?
Reduction, ma'am.
Reduction potential. So here we have no issues. So MnO4 minus, whose electrode or reduction potential is plus 1.510, and for water it is plus 1.223. So according to the shortcut, we know that electron will be moving from lower value to higher value, right? So MnO4, I mean, this species is gaining electron, right, Kana? So this is getting reduced. So MnO4 minus will get reduced to Mn2 plus. And accordingly, water will get oxidized. So water will get oxidized to, water will be oxidized to, okay, Santana Maharaj, we'll see, Kana, we'll see. Water will get oxidized to, see, that conversion is very important.
O2, ma'am. O2
Very
plus
good.
H.
Oxygen, right. So this is H2O. This is the structure of water. These two hydrogens will be removed as H plus. So I have oxygen with electrons, right? So 4 H plus ions were removed, and this electron will combine together. This electron and this electron will combine together. So actually 1, 2, 3, 4 electrons will be removed. So 2 moles of H2O will get oxidized to O2. Why it is called as oxidation? Because 4 electrons were removed. So 4 electrons plus 4H plus. See, water is getting oxidized to O2. Okay. So if you connect or if you dissolve MnO4 minus in water, then water will get oxidized and it will liberate O2. Okay. So answer is yes. Not first one and third one. And we have to find the value of E naught cell. And what is the formula to calculate E naught cell? E naught cathode minus E naught anode. So the metal or the species which is getting reduced is considered to be cathode, and the potential is 1.510 and anode's potential is 1.223. Now, could you please calculate and tell me the value of E naught cell?
0.287, ma'am.
Definitely it is positive. So answer is option B.
I confused them, so I said that.
Okay,
Sorry.
it happens. It happens. It happens. Fine. Now we'll move on to next question. Here they've given some graph and we have to find the axis. What could be the x-axis and what could be the y-axis? From the graph, what we can infer is if you increase the value of x, the value of y will not change. This is the inference. So we have to match the correct option.
Option D, ma'am.
Okay, option D. Fourth option, right?
Yes, ma'am.
Okay. Can you please justify something, Amarraj?
I mean, zero order reaction rate is independent of concentration, ma'am. And in first order reaction, T of is independent of concentration, ma'am.
That's
Option
it.
D.
That's it. See, as far as first order reaction is concerned, what is the formula of half-life period? 0.6932 divided by K1. So we have no concentration term here. So if you change the initial concentration also, there will not be any impact on half-life period. So in fourth option, x-axis is the concentration. What they mean is initial concentration of the reactant. If you change the initial concentration, definitely there will not be any change in the half-life period. So it can be option 4. And this one, in zero order reaction, of course, zero order reaction, the rate of the reaction is independent of the initial concentration, right? So here x-axis is initial concentration and y-axis is the rate of the reaction. So obviously answer is option D. Okay. I just want you to tell me the relationship between half-life period and initial concentration for zero order reaction. How it is related?
Ma'am, by 2,
Half-life
ma'am.
period.
T of is equal to
I mean, I want you to tell whether it is directly proportional or inversely proportional.
directly proportional, ma'am.
Directly proportional.
Yes,
Because as far as zero order reaction is concerned, half-life is equal to A naught
Concentration of A naught by 2 K1.
by
K1,
2
ma'am.
K naught. So here initial concentration and half-life of zero order reaction is directly proportional. Okay. How about second order reaction? How about second order reaction? Generally, we know the expression for nth order reaction, right? For half-life period. What is the expression? 2 power n minus 1 minus 1 divided by kn into n minus 1 into a naught power n minus 1. Here n is the order of the reaction, right? So for example, n is 2. Then T half is equal to...
Inversely.
Right, Kana, right. It is inversely proportional. So this is 2 minus 1, 1 minus 1 divided by K2 into 2 minus 1 is 1, A naught power 1. So half-life and initial concentration of the reactant is inversely proportional for second order. How about third order then? So generally what we can write is...
Square of A, ma'am. Inversely proportional to
Right,
square of
Kana,
A.
right. So here n is equal to 3. So T half is inversely proportional to A naught by 2. So as far as first order reaction is concerned, half-life period is independent of initial concentration of the reactant As far as zero order reaction is concerned, half-life period is directly proportional to the initial concentration of the reactant. And for rest of the orders, it is inversely proportional. Okay. Right. One more question. Okay, they're asking us to find the IUPAC name of this complex. Find the IUPAC nomenclature of the given complex. So obviously this is positively charged species and this is negatively charged species. So we have to name the cation first. So what will be the right answer?
Option A, ma'am.
Option?
Option C, ma'am.
Option C. Okay. See, in the cation, we have water as central atom and silver as central metal atom. I mean, water as ligand and Ag as central metal atom, right? So, while we are naming the complex, first we have to name the ligand. So, it is diaqua. So, definitely option B and option D were ruled out. And if you compare the option 1 and option C, everything were same except for the oxidation state of silver, right? Generally, what will be the oxidation state of silver? Will it be +1 or +2?
+1, ma'am.
+1. So definitely option C is wrong. Option 1 is right. I have another way to check whether the oxidation state of silver is +1 or +2. See, actually the total charge on the complex is 0, right? Now let us apply this third option. I have only one silver and the oxidation state of silver seems to be +2. And I have two water molecule and the charge of water is 0 plus here I have only one silver and the oxidation state of silver in the second complex is +2. I have two cyano group and the oxidation state or the valency of cyano group is -1 and total charge has to be 0, right? I just simplify this. 1 into 2 is 2. This is again 2 minus 2, which is must be equal to 0, but it is not equal to 0, right? So definitely option C is wrong. But if you substitute the value of oxidation, I mean, if you substitute the oxidation state of silver as +1, definitely it will be equal to 0. Let us check that also. I have only one silver, oxidation state of silver is +1. I have two water molecule, oxidation state of water is 0 because that is a neutral ligand. I have only one silver, oxidation state of silver is +1 again, and 2 into -1, which is equal to 0. So here this is 1 plus 1 minus 2. It is 0. So answer is option 1. Okay. Any doubt? Fine. Okay, Kana. Right. All the best, guys. Do well. Please read the question. Okay. Actually, question might be very easy, but in that 10 no, we will not read the question properly. Please read the question and please mark the right one. Okay.
Thank you, ma'am.
Okay, then okay. All
Thank
the
you,
best.
madam. Students, if you have any specific queries, you can send in the group. Madam will be answering, but class won't be there next week. You take the whole week for your own studies. That would be better. Work out that kind of a strategy, what you wanted to do in the next 10 days and how do we approach this exam and things like that. So that's very, very important. All the best to all of you. And you must be having your own strategy to face this particular exam. Use the strategy and then come up with the flying colors. Thank you, madam.
Thank you.
Thank you, sir.
Nivedita, madam, thank you. We will
Thank you, sir. Thank you.
talk to you sometime.
Okay, sir.
Thank you, sir. Thank you, ma'am.
Thank you,
Bye,
ma.
guys.
Thank
Bye-bye.
you. Thank you.